Hello and welcome to another Bentley Davey Tutors video. I'm Luke and today I'll be going through the idea of natural environments in geography and also looking at the case study of the Great Bear Rainforest in Canada. As you can see, unlike our last few videos, Jeremy is not here today. He's not with us anymore. He was fired for his new haircut, so you won't be seeing him for a while. Before I start, I'd like to give thanks to Oliver Yui, who dedicated his very important time and work to writing the majority of this video. So if anything is wrong, just blame him rather than me. And also stay around to the end for an exciting announcement about something new that Jeremy and I have been working on. So after that, let's get into geography. So to start, I'll go through a few key terms which are important to know. There are a range of these terms which will be used throughout the video, so I'll just go through them now so you know what I'm talking about. Firstly, a biome, which is a vegetation community occupying a large part of the Earth's surface. Ecosystem, which is a community of interacting plants and animals or organisms and their physical surroundings. Resilience, which is the capacity of an ecosystem to respond to disturbance, natural or human, by resisting damage and recovering quickly. The biosphere, which is the sum of all the parts of the biome and ecosystems. Community, a population of specific species. Population, a group of only one type of species, and an organism, which is an individual organism with a species. And finally, biomass, which is the dry rate of all organic matter contained within organisms in an ecosystem or biome. After that, we'll go into the functioning of ecosystems. So ecosystems are made up of non-living or abiotic and living biotic factors. These components of the ecosystem all work together to allow the ecosystem to operate. The best way of describing these interactions is by dividing an ecosystem into the four spheres. The biosphere, which is all of the living things. The atmosphere, which are the layers of gas surrounding the Earth. The hydrosphere, which is all the water. And the lithosphere, which is the rocks and minerals, including the soil. In geography, interactions between any of these spheres within an ecosystem is called a biophysical interaction. In the Great Bear Rainforest, there are many examples of biophysical interactions which are integral to the continued functioning of the ecosystem. These include the interaction of mountains and the hydrosphere. So the steep mountains in the GBRF act as a gigantic wall, causing water stored in clouds to hit the mountain, rise up, and drop their moisture over the rainforest. This is known as orographic rainfall, and is one of the key reasons that the GBRF receives a lot of rainfall each year. Another example is the interaction of the biosphere and the hydrosphere. The large amount of rainfall that the GBRF receives allows the organisms to prosper. Water is necessary for survival because it allows plants to photosynthesize and produce food which is then consumed by animals as part of the energy flow. These are two examples out of hundreds of interactions in the GBRF that are very useful to know and refer to when answering a question about the functioning of the ecosystem. The next topic is the energy flow. Energy flow is quite a self-explanatory concept as it simply relates to the movement of energy throughout an ecosystem. In geography, we represent the flow of energy in a food chain, or more broadly, for a whole ecosystem, a food web. Here are some important features of a food web to remember. At the bottom, there are the producers, which are the plants in the ecosystem. They gain energy by undergoing the process of photosynthesis, which is a process driven by the sun's energy. These organisms are the source of all energy in an ecosystem. The organisms that these plants eat are called first-order consumers, and this is where the first transfer of energy occurs within an ecosystem. However, only 10% of the energy produced by the producers is passed down to the first-order consumers. This is because the other 90% is lost in other forms of energy, such as heat or when a plant dies. Most of the energy is transferred into the ground through decomposition. The food web then continues through different trophic levels. First-order consumers, second-order consumers, third-order consumers, and so on until it reaches the apex predator, which is not eaten by anything, therefore ending the flow of energy in the ecosystem. A really important example of energy flow in the GBRF, or the Great Bear Rainforest, to remember is the relationship between salmon and its predators, including wolves, bears, otters, and ravens. The salmon is an abundant species in the GBRF, which makes them obvious food sources to these predators. The wolves, bears, otters, and ravens almost primarily rely on salmon to gain their energy that is necessary for survival when salmon migrate to the Great Bear Rainforest during the heavy autumn rains. If you want to know more about the flow of ecosystem, I think I talk about it in one of the science videos I did last year. It would be Earth and Environmental Science at a year level. So if you want to touch up on that, you can go watch that video as well. The next topic I'll talk about is the geographical processes. Every ecosystem is made up of a variety of geographical processes. These processes always include the four spheres mentioned earlier, the biosphere, atmosphere, hydrosphere, and lithosphere, and the interactions within and between these spheres. I've already gone through multiple of these geographic processes, including energy flow in an ecosystem and a range of biophysical interactions. To ensure that we've covered all these processes, however, I'll explain a few more and recap a few. So firstly, the water cycle. The water cycle is the flow of water in the world. I'm sure most of you remember studying the water cycle last year in science or previous years other than that. But the water cycle starts with evaporation or transpiration, where water on the ground or in plants turns into gas particles in the atmosphere, and these particles then condense, forming clouds, and then when dense enough, the water falls to the ground through precipitation, which is rainfall. The process of runoff then returns the water particles to bodies of water, such as the ocean or rivers where it originally evaporated from. Next is the nutrient cycle. The nutrient cycle involves the movement of dead organisms in the ground, which then become nutrients which enrich the soil and help plants to grow. Plant and animal matter is broken down by decomposers into soil, and from there the soil absorbs the decomposed nutrients, and then plants absorb these nutrients to help them grow. Next is the carbon cycle. The carbon cycle involves a number of processes which cycle carbon in the world. Carbon enters organisms through plants, which use carbon dioxide for photosynthesis. This carbon is then released from plants and animals through respiration. Carbon is also cycled into the ground when dead organisms are decomposed, and many of these dead organisms then become fossil fuels for many thousands of years, which we are now using to produce energy, such as like fossil fuels using petrols and stuff like that. And through the process of combustion, the carbon is released into the atmosphere. Finally, the nitrogen cycle, and the nitrogen cycle is also involved in a cycle through the atmosphere, organisms and the ground. The atmosphere is largely made up of nitrogen, which is then cycled into the soil. The nitrogen is then fixed into the ground by bacteria before nitrifying bacteria turns nitrogen into certain molecular structure able to be used by plants or returned to the atmosphere. From plants, the nitrogen is cycled to animals or returned to the soil through dead organic material, which is decomposed. Finally, before I go on to the Great Bear Rainforest case study, I'll talk about the productivity of biomes. The geographical concept of the productivity of biomes refers to the rate at which primary producers in an ecosystem convert the sun's light into energy through the process of photosynthesis. Ecosystems with high gross primary productivity have a larger biomass. And as I mentioned before, biomass is defined as the weight of all organic matter contained within organisms of an ecosystem or biome. So now I'll move on to the Great Bear Rainforest, and I'll do an overview, talk about a few points such as indigenous people, human impacts, and environmental management. So to give you an overview of the Great Bear Rainforest, here are some important details to remember. The Great Bear Rainforest contains one of the largest biomasses in the world, meaning there is large biodiversity. The absolute location is between 51 degrees and 54 degrees north in latitude and 130 degrees west in longitude. The relative location of the GBRF is on the west coast of Canada along the Pacific Ocean and is located in the province of British Columbia north of Vancouver. The Great Bear Rainforest is classified as a temperate rainforest. It is made up of many islands and fjords with mountainous terrain and ground covered by wet soils and grasses due to the large amount of rain and rainfall the rainforest receives. And finally, on average, the GBRF receives more than 4,600 millimeters of rainfall per year. And the reason that there is such a large amount of rainfall is because of the warm ocean currents along the coastline, which increase the evaporation of water, as well as the orographic rainfall as a result of the mountains, as I talked about earlier. Next, I'll talk about the indigenous people in the GBRF. One group of indigenous people who live in the Great Bear Rainforest are called the Gitxaala people. I probably pronounced that wrong, but I'll put the spelling up. These people have a very deep connection with the land, and they consider themselves to be brothers with the animals there. There's also a type of bear which can be found in the Great Bear Rainforest called the spirit bear, and the spirit bear is a sacred animal for these people because they are so rare and they believe that those bears were specifically made by their creators. I've talked about the function of the ecosystem, and I covered a few examples earlier, and also about the animal interactions, talking about salmon and how they're the energy flow of that throughout that ecosystem with the other predators that are there. So now I'll talk about the human impacts. So the humans have a major impact on the Great Bear Rainforest through a number of processes, and this includes things like mining, forestry practices like logging, agricultural practices, and energy projects. These human practices can alter the natural landscapes, and when done in large amounts can contribute to the destruction of natural habitats and disruption to the natural processes of an ecosystem. That is why there have been a number of management plans implemented by the Canadian government in recent years to conserve and protect the GBRF which is a fundamental ecosystem for not only Canada but the whole world. The final topic is about environmental management. So there are 3 different types of strategies when it comes to environmental challenges. Firstly, there is a human-centered approach. This approach looks more at what is best for humans and has a focus on the economy. For example, a human-centered approach might look at logging parts of the forest because then they can sell the wood, which is then good for the economy. Next, there is the earth-centered approach, and this has a focus on the restoration of ecosystems, and it aims to bring the ecosystem back to its original state before any human intervention. And finally, there's stewardship, and that's pretty much in the middle of the previous 2 approaches. It allows for the sustainability of the environment, but also allows for human activity for today and the future in a more environmentally friendly way. The Great Bear Rainforest is managed in a stewardship approach. After the introduction of the 2016 Great Bear Rainforest Land Use Order, about 85% of the forest is protected, and the other 15% is able to be used for human use, such as logging. So that's all for the geography so far, and also the case study of the Great Bear Rainforest. Make sure to go over some geography skills, such as knowing the different types of maps, and other skills such as grid and area references and scale and aspect and other things like that, including things like interpreting topographic maps, climate graphs, and choropleth maps. And I'm sure all of you have been watching just to hear the announcement that Jeremy and I have. So sometime this week or next week, we're planning on creating this satirical news show. We're planning on calling it News for Views. It's a very trendy name which Jeremy came up with. So we're looking just to be able to share the news with you guys, but also have it in a funny, entertaining way. So hopefully you can get a bit of a laugh out of that. So that'll be coming in the near future, and Jeremy and I will let you know more about that sooner to the release date. So thanks for watching, and I'll see you guys next time.